Okay, we have a test in here tomorrow. The test is over Chapter 2, Sections 3 through 5. Now, I gave you guys this review worksheet because in the past, this is the test that my students usually struggle with. I don't know why. There's a ton of information. I do get that. It is hard, but my tests come straight from the worksheets. Like, do we all understand that? I know the worksheets are hard. Worksheets are hard. God bless you. I get it. Okay, now with that being said, what this worksheet is it literally was my oldest test that I have. And I simply changed it from review worksheet to from test to review worksheet. I do not reinvent the wheel. I give more problems, I change problems, but the format looks exactly the same. I may have eliminated questions to shorten the length of the test. Do we all understand that? The directions will be the same. The layout will be the same. Do we all understand what I just said? Now, I will tell you this. Over my years of teaching, I have lightened up and become nicer with my problems. Straight up. My problems are nicer. They're not as hard. And it makes you realize that you understand what you're doing more because I have made it more, I've made the nicer numbers appear in your answers, which is what we need to understand the most, okay? So, as I'm doing the review, there's going to be different problems in the review than what there is in this worksheet. I'm not going to do the worksheet for you. I have already done the worksheet for you, and I have already posted those worksheet answers on Google Classroom. Okay, they're there for you. So do this, and as you do it, my work is not on there. I repeat, my work is not on Google Classroom. Only the answers are on Google Classroom. So as you're doing this, go ahead and check to pull up the answer and make sure that you're doing it correctly. Any questions over what I just said about the review worksheet? If you know how to do this review worksheet, there will be no surprises on the test tomorrow. I promise. Okay? Now, with that being said, let's go ahead and do the review that I have in class today. So get out a sheet of paper and we're going to go ahead and do this together. I want you to remain calm while we're doing this and do not freak out. I want you to have your calculator with you so that we can go over this and that you know what you're doing. Are we ready? Number one, it says to divide each of the following polynomials, x to the fourth plus 4x squared plus 12 all over x squared plus 2. Can I do synthetic division on this? You're shaking your heads no. Why can I not do synthetic division on this? Nope. Nope. Because you can only do synthetic division whenever you're dividing by degree of 1. I'm dividing by degree 2. Do we all understand that? Which forces my hand and makes me use long division rather than synthetic division. Do we all understand what I just said? So I have to use long division on this. So how do I go about that? I put x squared plus 2 on the outside, and I put x to the fourth plus I am missing x cubed, so I put a 0x cubed there as a placeholder, plus 4x squared, put a missing 0x, so I put a placeholder there, and plus 12. Does everybody see what I just did, yes or no? Are we good? Okay, now you're going to ask yourself the question, what do I multiply x squared by to obtain x to the fourth? X squared. So I'm going to put x squared above the x squared term. And on the diagonal, I'm going to multiply x squared times x squared is x to the fourth. X squared times 2 is going to be 2x squared. Please be certain that you're putting them under the correct like terms. We all understand that. I'm going to change the signs by simply subtracting them. Those cancel out. I don't need an x cubed. And 4x squared minus 2x squared is going to be 2x squared plus 0x plus 12. What do I multiply x squared to obtain a 2x squared? A 2. So I have a plus 2 above the 12 position. Yes? 2 times x squared is 2x squared. 2 times 2 is going to be a 4. Again, that goes underneath the x, the 12. I'm going to change the signs of each of them. Those cancel out. I don't need the 0x, and 12 take away 4 is 8. What is 8 known as? Your remainder. So to write this appropriately, this is going to be an x squared plus a 2 plus an 8 divided by my divisor, which is x squared plus 2. You will have one long division problem on the test tomorrow. Do we understand that? Now, if you look at the review worksheet that I gave you, problem number 1, what do I multiply 2x squared by to obtain a 1x to the 4th? What do I multiply a 2x squared by to obtain a 1x squared to the 4th? Yes. So you're going to multiply by 1/2 x squared. So I promised you on the review sheet, number 1, it is fractions that you're going to be utilizing. Do we all get that? We good? All right, the next set of instructions says write the function in the form of f of x equals x minus k times q of x plus r at x. Okay? What this means is I want you to do synthetic division. Do we all understand that? So I'm going to have synthetic division. 3 over 2 goes inside the box. 3x cubed minus 4x squared plus 0x plus a 5. Did you see how I put the placeholder in there? And I promise you, tomorrow on the test, you 100% are going to have 0 as a placeholder in there somewhere. You with me? You need to grab your calculator, and I want you to not mess this up because you're trying to do mental math. Okay? Grab the calculator and do the math. Drop down the 3. 3 times 3 divided by 2 is going to be 9 over 2. 9 divided by 2 plus 4 is going to give you, nope, that's not 9 divided by 2. 9 divided by 2 minus 4 is going to give you 1/2. Do you all understand that? Then take that answer and multiply it by 3 divided by 2. What does that give you? 3 over 4 plus 0 gives you 3 over 4. Multiplying this by 3 divided by 2, and that's going to give you 9 over 8. Plus 5 is going to give you 49 over 8. What is 49 over 8 representing? The remainder. Now, this problem is all about writing it in the correct format. So I'm going to have an x minus a 3 over 2. What degree does this green values turn into? What polynomial degree is that? Degree 2. So this is going to be 3x squared plus 1/2 x plus 3/4. And then you're going to simply tack on the remainder, which is 49 over 8. That is how the directions want you to write this polynomial. Do we all understand that, yes or no? I will have a point for the x minus 3 over 2, 3 points for this polynomial here, and then a point for the remainder. Does that make sense? We good? This is a big test. Okay, the next set of instructions say to do this. Use synthetic division to evaluate each function value. Generally speaking, my students forget the very first 4 words and say evaluate. Oh, okay, I'm just going to plug and chug, right? Don't do that. The directions are very clear. It says use synthetic division to evaluate. So you actually have to do synthetic division here. So the 8 goes on the outside in a half box. And then you're going to have 4x cubed 0x squared minus 13x plus 10. Notice, again, there's a place value there that you have to put a placeholder in. Do we all understand that? I will have it on the test tomorrow. You cannot forget to check. Degree 3. So this is 3, 2, 1, 0. Remember how I checked every time just like that? Drop down the 4. 4 times 8 is 32. Plus 0 is 32. What is 32 times 4 times 8? It's going to be 256 minus 13 gives you 243 times 8 plus 10. Now, what this means is it wants you to give me what f of 8 is. Well, f of 8 is actually 1,954. Do we all understand that? We good? Your evaluation is when doing synthetic division, it's the remainder. We good? Okay, the next thing. This will say determine if x plus k is a factor of p of x. So circle yes or no, it's a factor. Then, by doing synthetic division and then state the remainder. So what do you have to do on this problem? You have to do synthetic division. What am I doing synthetic division at? Negative 3i. The biggest mistake students make on this is they don't solve this for 0. And they try to put x's in with there. When they do synthetic division, I have a whole bunch of people always throwing x's in there. No, no, no. We don't throw any variables in with a 3i. Okay? So what you're doing synthetic division at is negative 3i. Are we good? 1x cubed, 1x squared, leaving space, there's a 9, and then leaving space, there's another 9. Checking your powers, 3, 2, 1, 0. Did I miss any? No, I did not. Drop down the 1, multiply on the diagonal. Why did I place the negative 3i to the right of the 1 below it? Because I have to leave room for the real number, and then to the left of it, or to the right of it, the imaginary number part of it. Do we all understand that? So you're going to have 1 minus 3i. Now, I want you to utilize a calculator when you do this. So I'm going to go ahead and I'm going to get a new calculator page. And I want you to type in negative 3 times I, which is in the pi, parenthesis, 1 minus 3i, which is in the pi, and hit enter. And it's going to give you the negative 9 minus 3i. And then I want you to use the calculator. Yes, you know that's going to cancel, but I want you to have that running tally in your calculator. Say plus 9. And that's going to give you just the negative 3i. Do we all understand that? By having that running tally in your calculator, you will have less mistakes whenever you multiply your imaginary numbers, because now we're going to take that answer and we're going to multiply it by a negative 3i and hit enter. And what does that give you? Negative 9. So what can you conclude? Is this a factor, yes or no? Yes. And what is the remainder? 0. You 100% will have something like this on the test. On the review sheet, this is just like problems 11 through 13. Do we understand that? If you circle no, just plain and simply give me the remainder, the last number in your synthetic division. Do we all understand that? Okay, let's go to the next thing. The next thing is to find the polynomial of the equation with the given roots. I give you root 1 is equal to 2, and root 2 is equal to negative 4 plus I. As soon as you see that you have an imaginary number, you immediately can say, oh, Well, that means root 3 is negative 4 minus I, because that is the conjugate of the complex number negative 4 plus I, which is root 2. Do we all understand what I just said? We good? Yeah? Okay, now what am I going to do with all of these? I have to find the polynomial. So I have to have them all equal x. So x is equal to 2, x is equal to negative 4, plus or minus I. Do we see that? Why am I writing that as 1? Because we're going to make it 1 anyway, right? So I'm going to take the real numbers over to the other side. So x minus 2 is equal to 0, and x plus 4 is equal to plus or minus I. Now, what do I not like about the x plus 4 is equal to plus or minus I? The plus or minus. And I obtained that by taking the square root of both sides. So how do I get rid of this, the plus or minus? I'm going to square both sides. So that's going to give me an x plus a 4 times an x plus a 4 is equal to, what is I squared going to be then? A negative 1. So I'm going to FOIL the left-hand side. X squared plus 8x. 4x plus 4x plus 16 is equal to negative 1. Does everybody understand what I did? I FOILed that. Now bring that negative 1 on the other side and combine like terms. X squared plus 8x plus 17 is equal to 0. Now, can anybody tell me what I'm going to do with these two items right here? I'm going to multiply them together because this is degree 3. So therefore, I have to have an x cubed as my answer. Currently, I don't. So I'm going to have an x minus a 2 times an x squared plus an 8x plus a 17 is equal to 0. So this is going to give me an x cubed plus an 8x squared plus a 17x minus a 2x squared minus a 16x minus a 34 is all equal to 0. Yes? So now simply combine like terms. 8x squared minus 2x squared is going to give you a plus 6x squared. 17x minus 16x is going to give you a 1x minus a 34. This is the polynomial that I am looking for. And this is just like problems for 14 and 15 on the review worksheet. Do we understand that, yes or no? Okay. The kicker on the test is if I give you one imaginary number, what must you always check to make sure of? That the conjugate is there. And if the conjugate is not there, you have got to add it. We all good? Okay. Now, this is the big problems, right? These are the big chunk ones, yes? What's the very first thing it tells you to do? P over Q values. Now, on your review sheet, do you see how I gave you a line for P and I gave you a line for Q? Listen very closely. On the test, I did not give you a line for P and I did not give you a line for Q. I gave you a line for P divided by Q. Do we all understand that? So you may have to put that someplace else on your paper for you to make sure that you don't mess up. Now, what is P in this case? 18. What are all the factors of 18? Plus or minus 1, 2, 3, 6, 9, 18. Do we all see that? Yes or no? Now, what is Q? What are all the factors of 4? Plus or minus 1, 2, and 4. Yep. You mean like really long, obnoxious, ridiculous ones? I wasn't that mean. P divided by Q is plus or minus. I'm literally going to take every one of those values and divide it by 1. So 1, 2, 3, 6, 9, 18. Now I'm going to take every one of those values and divide them by 2. I am not going to repeat any of the ones that are currently already listed in green. So 1/2 is new. 2 divided by 2 is 1. It's already in the list. 3 divided by 2 is new. 6 divided by 2 is 3. It's in the list. 9 divided by 2 is new. And 18 divided by 2 is 9, and it's already in the list. So now I'm going to go to the next one, which is going to be the 4. And I'm going to divide each of those terms by 4. So that's going to give me a 1/4. A 1/4. 2/4 is what? 1/2. 3/4 I don't have in there. 6/4. What's 6/4? Is it in the list already? 9/4. I have to add it. How about 18/4? What's 18/4 reduced down to? Does everybody see how I have all of my numbers now? Yes or no? I promise you, doing it in the method I just showed you is the best way to ensure you are not missing any P over Q values. Now, this is not on the test because this is something mentally you should be doing every time you do this. So what is my window size going to be? Negative 19 to 19. Why is this mentally important for you to check? You need to check to make certain that the window size of your graph is large enough for you to make sure that you have seen every possible rational zero that you can see and irrational zero. Do we all understand that? We good? Okay. Now, what's the next thing it wants me to do? It wants me to do P over Q, or Descartes, sorry. So positive roots. I'm going to count my positive, I'm going to count my changes and signs from positive, negative, negative, positive in my original polynomial. So positive 4 to positive 7, nothing. Positive 7 to negative 11, there's 1. Negative 11 to negative 18, nothing. Do we all understand that? Which means I have one sign change that is positive. Now, how do I find the negative sign change? I'm going to do f at negative x. What changes when I do f at negative x? Only the odd roots. So negative 4x cubed changes to negative 4x cubed. 7x squared stays. Minus 11 turns to plus 11. And minus 18 stays as minus 18. Do we all understand that, yes or no? So how many sign changes do I have here? 1, 2. So I'm going to have 2 or 0. So my lovely little chart, 1 is going to be paired with 2 or 1 is going to be paired with 0. How many total roots are in this polynomial? 3. So I have to have 3 both times. So how many are left to be imaginary in row 1? How many are left to be imaginary in row 2? Do we all understand that? Now, at this point, what should we do next? We should graph this. So I'm going to go over to my graphing calculator. I am going to add a new page. And this is going to be 4x to the third. Then what was it? And I'm going to graph it. Now, mentally, I'm going to go ahead and I'm going to drag this away so it's out of the way. Now, mentally, I need to look at my window size. Negative 19 to 19 is what my window size should be. My question is do I see all of my roots right now without changing my window? I absolutely do, so it's not necessary to change my window. Now, how many negative roots do you see up there? 2, and how many positive? So I'm going to come back over here and I'm going to highlight what I know I'm supposed to be looking for. Do we all understand that, yes or no? Now, the next thing we need to do, this is the same problem, is I want to find root 1, root 2, and root 3. Because guess what? My goal is to factor this thing completely. So I'm going to go back over to my graphing calculator, and I'm going to hit menu, analyze graph 0, and I get 1.63. What is your gut telling you about that number? It's what? It is a fraction, you think? Well, do I have any fractions in my P over Q list that are approximately 1.63? So that's something you need to check here in a little bit. Okay? It's either rational in our fractional list or it's going to be irrational. So let's do this again. Menu, analyze graph, 0. Negative, oh, come on. Negative 1.38. And now I'm going to do it again. Menu, analyze graph, 0. And then negative 2, 0. Do we see that? Negative 2, 0. Do we like that root? We really like that root. You know why? I know it's in my list. So I'm going to immediately put negative 2 here. The other ones, I don't really know what those are, do I? Okay? So I do know that my P over Q list, I have 3 over 2, which is exactly 1.5. Is that helpful for me? No. I have 9 over 2, which is over 1. And I have 1/4, which is 0.24, and I have 3/4, which is 0.75, and I have 9/4. Is 9/4 going to give me what I want either? So what can you conclude about those other two decimals? They're irrational. So that means I have to do what here? I'm going to do synthetic division at negative 2. So I have 4, 7, negative 11, negative 18. Drop down the 4. 4 times negative 2 is? Plus 7 is negative 1. Negative 1 times negative 2 is 2. This gives me a negative 9. This gives me 18. And this gives me a 0. What degree is this polynomial right here? It is degree 2. And the polynomial I have is 4x squared minus x minus 9 is equal to 0. What do you think I need to do with that? I need to do the quadratic formula because guess what? We know the other two roots are irrational, and I can't factor this. So I have to use the quadratic formula. Do we all understand that? So that means that A is going to be 4, B is going to be negative 1, and C is going to be negative 9. So this is going to be negative B plus or minus B squared minus 4 times A times C all over 2A, and I plug and chug. Negative times negative 1 plus or minus negative 1 squared minus 4 times 9, which is a negative, all over 2 times 4. Yes? A double negative creates a positive. Negative 1 squared is 1. A double negative creates a positive there. 4 times 4 is 16, and 16 times 9 is 144, all over 8. And what is 1 plus 144? 145. Now here's my question. If you take 145 and divide it by 5, what does that give you? Give me that. It gives you 29, right? 29 is prime, so therefore there's no perfect squares within 145. So I can't do anything with that, can I? Now this is what I'm telling you. This means that root 2 is 1 plus the square root of 145 over 8. And root 3 is going to be 1 minus the square root of 145 over 8. How can I confirm that what I just said is accurate? Well, I'm going to go to a calculator page, and I'm going to type in there, control division key, 1 plus the square root of 145, 8. And what decimal is that? Is that what we wanted it to be from previously? Yes. Control division, 1 minus the square root of 145 over 8. And that's negative 1.38. Was that correct? Yes. So I just found my two irrational roots. So now I want to put this in my factored form. That's going to be x plus 2 times x minus 1 plus the square root of 145 over 8. And x minus 1 minus the square root of 145 over 8. Do we all understand that that's in its most factored form? Yes? Okay, the last thing that I want to show you is going to be this. Factor the following given the root. Do these problems the easiest way that you can. Meaning I'm not requiring you to do I'm not requiring you to do P over Q or Descartes. You with me? I'm requiring you to look at this problem and to figure out how you're going to do this easiest way. So, what should you first start with? How would you analyze this and figure out what you need to do? The conjugate. You're absolutely right. I need to have the conjugate of this problem, which is going to be 3 plus, nope, come on, negative 3 minus I. And how many roots does this thing have? 3 roots. So I need to have root 3. Now, be really smart right now. It's probably going to be a real root. So what could I do? I could totally graph this thing. I'm not asking you to do anything that you don't already know. So all we have to do is go over to our graphing calculator, and I'm going to graph this thing. Okay? Can somebody read off that polynomial for me? Did anybody write it down? Thank you, Kylie. Okay. Now, if you look at this thing, we know 2 of them are imaginary, right? Can I see the other one? Is it crossing the x-axis? Sure is. Menu, analyze graph, 0, right, left, and what is it? 0.25, which is 1/4. Do I have to do anything to this problem? No. All I have to do is say x plus 3 minus I, x plus 3 plus I, and then x minus 1/4. Now, on the test, am I probably going to give you the 1/4? Probably not. It's probably all going to be imaginary. So what are you going to probably have to do? Synthetic division at negative 3 plus I, synthetic division at negative 3 minus I, and then probably go ahead and use the quadratic formula to find the 2 irrational or the 2 imaginary. Do we all understand that? The test is tomorrow. Please work on the review worksheet so that you know what you're doing. Any questions over what I just said? Go ahead. I'm sorry.
I was